partitioning. Now, what can happen when we're dealing with really large data sets is that large tables can be difficult to query effectively because they have so much data, and especially if you're scanning or you have to maintain very large indexes. So what partitioning does is it splits tables by either rows or columns into these subsections, which we call partitions. Now, horizontal partitioning is a way of limiting the amount of data we have to scan to a subset of a set of columns. We can have local indexes for each different partition. So in this example, we have a large table which is broken down into 3 different partitions. We could have 3 distinct sets of local indexes. And so our indexes would be smaller, scanning the indexes would be smaller, or if we needed to scan the entire partition, the amount of data would be smaller. And also, partitioning makes adding and deleting data efficient, especially if you have like a time-based partition. It's very easy to say, drop off the oldest partition, just drop that partition, once that data, say, ages beyond whatever period of time you think it's useful for. Now, vertical partitioning is a little bit different from horizontal partitioning. With vertical partitioning, we're separating out columns. And this is in a way what columnar storage does. It's sort of extreme vertical partitioning in that we increase the number of rows that can fit in a data block because we have fewer columns in each row. So when we're using a row-oriented storage system, this is one way to start to get some of those advantages of columnar storage. Now we can have global indexes for each partition. So we're still covering the entire table like all global indexes, but we can still reduce I/O because when we fetch data, we're going to fetch a single block, or actually, some number of data blocks, but those data blocks will have the equivalent of more rows than if we had additional columns in the data block. And again, columnar storage has similar benefits. Now, range partitioning is a type of horizontal partitioning. And basically what it allows us to do is to partition on non-overlapping keys. So we'll identify a column or set of columns that is a partition key, and those will be distinct. And we will be able to sort of designate which partition a particular row of data goes into based on that key. Now, working with date is quite common. Also, numeric ranges are often used for range partitioning. And we could also use alphabetic ranges. List partitioning is a little bit different. We basically have a set of particular attributes. So, for example, if we wanted to work with tables with data from global sensors and we want to partition them by continent, we could do that. Again, it's non-overlapping keys, but there's some fixed list of values that we're going to be worked with. So that's the thing that's distinctive about list partitioning. Now, another option is hash partitioning. And here, basically what we do, we still identify a partition key, but then we apply a hash to that. And then we take the modulus of that hash to identify, for example, which partition to go to. So with hash partitioning, we might decide, we want 10 or 20 or 30 partitions. And then we'll pick a partition key. That partition key will be used when it's time to determine where a particular row should go. And we'll just do the mod operator on the hash of that partition. And then based on whether the mod result is 0 through 19, depending on where that lands, that'll determine which partition it should go into. Now, hash partitioning is useful when you don't have like a set of values that would make sense for list partitioning or other numeric or alphanumeric. Doesn't really make a lot of sense for range partitioning. It's also good if you want to make sure your data is evenly distributed. Hash partitioning will keep it balanced. Okay, so now I've switched over to pgadmin, which is a GUI tool we use for working with Postgres. And what I'd like to do now is to just do a quick example of creating a table with a range partition. I want to point out I'm using a Postgres database, and I'm in a database named Postgres. And right now I'm using a schema called IoT for Internet of Things. And so what I'm going to do is create a table, and I'm going to create it in the IoT schema, and I'm going to call it sensor measurement, or MSMT for short. And let's see, we will have a sensor ID, which will be an integer, and it should be not null. And we'll have a measurement date, which will be a date and not null, and let's measure temperature. And for simplicity, we're going to keep this as an int. We will assume there's no decimal places on temperature. Similarly with humidity, we'll call that an int. And that wraps up our list of attributes. But now I want to specify that I want to partition by, and I want to use range partitioning. So I want to partition by range over my measurement date. And I'll just execute that to create that table. And so basically I've created that table. And now what I need to do is actually create the partitions. And I do that by using actually the create table statement with the partition of option. So let me show what that looks like. So here we're going to create a partition, one for each month. And so I'm going to create a table and I'm going to call it IoT sensor measurement. And I'm going to call it year 2021, month 01. And I'm going to specify that this table is a partition of my IoT sensor measurement table. And now I need to specify what values. So I'm going to say for values from, and I'll specify a date, say 2021-01-01 to 2021-01-31. I'm going there. And then I will do the same. So let's say I want to do it for February as well. I won't do this for all 12 months, but I'll just do a couple partitions here so you can just get a sense of what the syntax looks like. So let's see, we'll want to change that to 20. Oh, and I made a mistake here. This should be 2021. This should be 2021. This should be 2021, 2021. And this should be actually 02. We'll change that February to 28. And this to 02. So we have our main table, which is IoT sensor measurement. And then we specify that we're going to use a date column. In this case, it's called measurement date. And now we're going to be creating the partitions themselves. Now, if we wanted to have a whole year's worth of partitions, we'd have 12 create table partition of statements like this. But instead of doing that, let's just run this. And it returns. And basically now we have a partition table. So that's the syntax. And the syntax, again, is similar for like list partitioning, hash partitioning. But again, the core idea here is you create like a main primary table, which specifies what the structure looks like. And then you create whatever partitions you need for that.